Dear students, today we'll see the third part on multiple choice questions on the subject FEEE. So, Fundamentals of Electrical and Electronics Engineering FEEE Part 3 section of multiple choice questions. So, let's see the first question here. Which of the following should be done before working on electrical equipment? The options are wear insulated gloves, use a metal ladder, keep the equipment plugged in, stand on a wet surface. So out of these options, which of the following should be done before working on electrical equipment? So out of these options, the option A is the right answer, that is wear insulated gloves. So here, if you see the reasoning for it, option A, wear insulated gloves, it is important to prioritize safety when working with electrical equipment. Wearing insulated gloves helps protect against electric shock and ensures a safer working environment. The other options are not safe practices and should be avoided. So here the other options what we had were using a metal ladder. It can be dangerous because metal conducts electricity, increasing the risk of electric shock. Option C, keeping the equipment plugged in possesses a risk of electrical shock. It is advisable to disconnect the equipment from the power source before working on it. Option D, standing on a wet surface increases the risk of electric shock since water is a good conductor of electricity. It is essential to work in dry conditions and on dry surfaces. So if you see all these options, option A is the right answer. That is, which of the following should be done before working on electrical equipment? It is option A, wear insulated gloves. Then we'll go to the next question. What is the purpose of ground fault circuit interrupter, GFCI? Options are to protect against electrical shocks, to regulate voltage levels, to increase energy efficiency, to prevent electrical fires. Now, if you see the definition of ground fault circuit interpreter, then the option A, that is to protect against electrical shocks, will be the right answer. So here you can see option A says to protect against electrical shocks, which is the right answer. And if you see the definition of GFCI, a ground fault circuit interrupter, GFCI, is a safety device designed to protect against electrical shocks by quickly shutting off the power to a circuit if it detects a ground fault or leakage of current. This helps prevent electric shock injuries, especially in areas where water and electricity may come into contact, such as bathrooms and kitchens. Then, for this question, what is the purpose of ground fault circuit interrupter, GFCI? Option A is the right answer, to protect against electrical shocks. Then we'll go to the next question. Which type of fire extinguisher is suitable for electrical fires? The options are water-based extinguisher, foam-based extinguisher, CO2, that is carbon dioxide extinguisher, or powder extinguisher. So out of this, the right answer is CO2 extinguisher, that is carbon dioxide extinguisher. So CO2 extinguisher, a CO2 carbon dioxide fire extinguisher, is suitable for electrical fires. CO2 extinguishers work by displacing the oxygen around the fire, thus smoothing it. They are appropriate for use on electrical fires because they leave no residue or water, minimizing the risk of damage to electrical equipment. The other extinguishers, that is option A, water-based extinguisher, and option B, foam-based extinguishers, are not recommended for electrical fires as water is a conductor of electricity. Option D, that is power extinguisher, can be used on electrical fires, but they may leave a residue that can be problematic in certain environments, and the discharge may damage sensitive electronic equipment. So to looking at all these options, option C, that is a carbon dioxide extinguisher, CO2 extinguisher, will be the right answer. That is, which type of fire extinguisher is suitable for electrical fires? The answer is CO2 extinguisher. Then we'll go to the next question. What should you do if you notice frayed or damaged electrical cords? The options are continue using them until they completely fail, repair them with tape or insulation, replace them with new cords, or ignore the damage as long as they still work. So out of these options, option C is the right answer. That is, we have to replace them with new cords. So replace them with new cords, option C. So if you notice frayed or damaged electrical cords, it is important to replace them with new cords. Using damaged cords can pose a significant risk of electrical shock or fire. Whereas the other option, that is or continuing to use damage cause until they completely fail as in option A, or attempting to repair them with tape or insulation as in option B is unsafe and can lead to hazardous situation. Ignoring the damage as in option D is also not advisable as it can compromise the safety of the electrical equipment and the surrounding environment. Always prioritize safety and replace damage caused promptly. So here for this question, what should you do if you notice frayed or damaged electrical cords? The right answer is replace them with new cords. Then we'll go to the next question. What is the purpose of an electrical lockout or tagout procedure? Options are to secure electrical equipment during maintenance or repair, to prevent unauthorized access to electrical systems, to increase energy efficiency, to regulate the flow of electricity. So, out of this, the first option, that is to secure electrical equipment during a maintenance or repair, is the right answer. So here we can see option A, to secure electrical equipment during maintenance or repair. The purpose of an electrical lockout or tagout procedure is to secure electrical equipment during maintenance or repair activities. This procedure involves isolating and locking out energy sources to prevent the accidental or unauthorized startup of equipment, ensuring the safety of personnel working on or near the equipment. This helps prevent electrical accidents and injuries during maintenance or repair work. So option A is the right answer. The other options, that option B, C, and D, do not accurately describe the primarily purpose of lockout or tagout procedures in the context of electrical safety. So here, what is the purpose of an electrical lockout or tagout procedure? Then the option A is the right answer. It is to secure electrical equipment during maintenance or repair. Then we'll go to the next question. Which of the following is not an example of electrical safety equipment? Not an example. So options are voltage tester, insulated gloves, wire cutter, or safety goggles. So if you see these options, option C, that is wire cutter, is not an example of electrical safety equipment. So here we can see a wire cutter is not typically considered electrical safety equipment. It is a tool used for cutting wires but does not provide protection against electrical shock. On the other hand, option A, voltage tester, is a piece of equipment used to test the presence of electrical voltage. Option B, insulated gloves, are worn to protect against electrical shock when working with live electrical components. Option D, safety goggles are used to protect the eyes from potential hazards, including those associated with electrical work. So the correct answer is option C, that is wire cutter. So which of the following is not an example of electrical safety equipment? It is wire cutter. Then we'll go to next question. What is the purpose of an electrical safety audit? To identify potential hazards and ensure compliance with safety regulations, to reduce electricity consumption, to test the efficiency of electrical equipment, to generate electricity from renewable sources. So out of this, option A is the right answer, to identify potential hazards and ensure compliance with safety regulations. So here you can see the purpose of an electrical safety audit is option A, to identify the potential hazards and ensure compliance with safety regulations. This is done to promote a safe working environment, prevent accidents, and meet regulatory standards. The other options, option B, C, and D, are not the primary objectives of an electrical safety audit. They are not primary objectives of an electrical safety audit. So if you see the options here, what is the purpose of an electrical safety audit? Option A is the right answer, to identify potential hazards and ensure compliance with safety regulations. Then we'll go to the next question. What is the recommended distance to maintain between electrical equipment and water sources? So out of these options, that is 1 foot or 3 feet or 6 feet or 10 feet, the option 3 feet is the right answer. So here the recommended distance between electrical equipment and water sources typically varies between local electrical codes and safety standards. However, a commonly recommended guideline is option B, that is 3 feet. It's important to note that specific requirements may vary and local regulation should be consulted to ensure compliance with the applicable standards in a given area. So overall, if you see a commonly recommended guideline is option B, that is 3 feet. What is the recommended distance between electrical equipment and water sources is option B, 3 feet. Then we'll go to next question. Which of the following is not a safe practice for using extension cords? The options are overloading the extension cord with multiple devices, using extension cords temporarily, not as a permanent solution, keeping extension cords away from high traffic areas, ensuring the extension cords is rated for the intended use. So here, option A is the right answer. Overloading the extension cord with multiple devices is not a safe practice. It's important to avoid overloading extension cords as this can lead to overheating and pose of fire hazards. Using extension cords within their specified capacity and not exceeding the recommended load is crucial for safety. The other options, option B, C, and D, are safe practices. Using extension cords temporarily, keeping them away from high traffic areas, and ensuring they are rated for the intended use contribute to safe and effective use. So here, which of the following is not a safe practice for using extension cords? So option A, overloading the extension cord with multiple devices, is the right answer. Then we'll go to the next question. What does the term electrical insulation mean? The options are the process of reducing energy consumption, the use of protective materials to prevent electrical shocks, the regulation of voltage levels in electrical systems, the grounding of electrical equipment. So out of these options, the use of protective materials to prevent electrical shock is the right answer. So here you can see option B, the use of protective material to prevent electrical shocks. The term electrical insulation refers to the use of materials that are non-conductive or have high resistance to electricity. This is done to prevent the flow of electric current and to isolate or insulate conductive paths from each other, reducing the risk of electrical shocks and ensuring the safety of people and equipment. So what does the term electrical insulation mean? So the right answer is option B, the use of protective materials to prevent electrical shocks. Thank you, students.